Okay, welcome to another IIT exam problem solution for advanced physics. This is from 2023 and this is section 1, and I've done problem 1 already, but just to say that in this section every question has 4 answers and you have to check every one of them and you have to mark only the correct answers you find. Okay, so this was the problem 1, which is done in another video, and now I'm looking at problem 2. This is the problem 2, and let me show you the full problem from problem 2, and this statement of the problem is about this test quite a bit of information about optics, and this is advanced information. All right, so this is a prism, and we're going to have a blue light and red light. So the refractive index of this prism is different for the blue light than for the red light. Okay, refractive prism, the blue light is given square root of 3, and for red light it's not given, and you have to find out, okay, from the given situation. All right, and this also, it's a plane polarized blue light, and they're both plane polarized. All right, so we're talking about the polarized light now, and the prism, when the blue light goes, there is no reflection here, so it's coming at an incidence which is polarizing angle or Brester angle for this interface for this light. But here you have this angle is not Brester's angle for the red light. Okay, so the angle, this apex angle, is not given, and actually you have to find the apex angle. That's one of the questions, the angle of the prism 45 degrees. So that is about apex here, that angle. Okay, you can try to do this problem, see if you can guess which one of this is correct. I guess don't guess, you actually figure out what is correct, and because in this section you are not allowed to guess actually, because if you do a guess and turns out wrong, you get negative mark, and so I wouldn't guess unless you can eliminate and you are very sure about your guess and you're willing to take that risk. Okay, that's just a strategy of how people deal with the exam, but I like to when this is like a negative marking of such heavy amount, it's best to know it for sure. When you say which is right, it's best to just go with a 0 than -2. Okay. All right, first of all, this A is correct, and that one you probably either know it from before some studies. This actually a little bit of stupid problem, because you either know it or you don't know it. You just from your previous studies or memorization, whatever you are. So it comes from the fact that when you study let's see, when you study a reflection, you can have so you have a reflection and here's a refraction. When you're studying like this, then the plane of polarization, this plane that we're looking at, this plane in which these 3 rays, this is plane of incidence. Then electric field can be perpendicular to it, so that will be, if you have this kind of electric field, E field perpendicular in the wave, electromagnetic wave corresponding to this ray, so electric field is perpendicular to this plane. So it can be one situation. Another situation will be electric is in the plane, because it has to be perpendicular to the path of the ray, right? So this electric field is parallel to the plane of incidence. We're talking plane of incidence, okay? So this is what this question is saying, is polarized in the plane. So this also called polarized in the plane of incidence. So only in this case you're going to have a Brewster angle, where this ray will vanish. There will be no this ray. There will be just this coming into that. All right. So you either know or not. So we already can see that from this presentation here, A is correct. Okay. So we get A right, and then we have to work for this other guys. We have to find angle of incidence, refractive index of, in this case, for the red light, and then you have to know angle of refraction for the blue light in the air exit plane. What is the angle? Is it 60 degrees or not? So that one also you need to know the definition. So if I have a okay, so if I have this like a prism, and I send a ray and it bends around like that and comes out like that, then if you extend this, so that's the situation, right? And if you expand this backward, this angle is the deviation. But then you have a normal to this normal. This is the incidence angle, and this will be, we'll call it refraction angle, first one, and then there is another 90 degrees to this interface. This is, we'll call it I prime, this incidence angle. This reflected ray becomes the incident at this interface. So like interface 1 and interface 2. And so this angle here, this is the normal 2, this is the normal 1. This angle here is what is coming out. This is the refracted ray, our exit ray. Okay. Now, and this angle over here, we'll call it A, apex A. And this 90 degrees, they actually meets up. This is not 90 degrees. This is some angle, say phi or something. You know. Now you, and then there is this angle over here. Let's call it psi. Okay. So all of this angle, when you study plane prism, you really need to know different things. Okay. So for our case, what we need to know is what is this angle deviation, a general formula for deviation. So things that maybe you should have learned earlier. I don't know if we're going. So this is very recurring part of test. So I would definitely study a prism when I go into this test. So delta is simply going to be I plus E minus A. So I every time memorize it, or you can just I don't know. I think memorizing some formulas so works. So this A minus R. So I actually worked it out, and it sometimes takes me time to work it out. And this is the Snell's law, and So this is Snell's law, and this is the formula that you either have to derive it or you have to just memorize it, okay, on this spot. Okay, blue light. We're going to work out blue light, and we're going to do NB, and for red light NR, and for blue light NB, I think it's given is NB equals to I'm looking at the given problem, so I'm just going to write down my okay, so let's see, it's pretty hard to do this in a very tight spot. So this is square root of 3, and so in the blue, what's given is the deviation is 60 degrees. So here is the deviation, delta equals 60 degrees. Here the deviation is delta equals to delta min. It's the minimum deviation. So actually minimum deviation is from the symmetry. You can actually guess the formula, but this would mean you really need a formula for the minimum deviation, and that's so for the refractive index and sine A over 2 and sine A plus delta m over 2. So you can see a lot of people memorize this formula in addition to memorizing these formulas. But this one, if you don't remember it, you can say, okay, if I shoot it from this side, it's going to come out symmetric on the other side, so this will be minimum deviation. So and from there you can actually find this very quickly. I don't want to spend time deriving it. Okay, so over here we have another information, which is I here is the Brester's angle is equal to Brester's angle theta b. That has to be so another thing, remember, tangent theta b is the ratio of this refractive index over this refractive index. Okay, so that's just equal to n of the blue light. So if I know, so tangent I will be square root of 3, so this it came in at 60 degrees. So I equals to 60 degrees. So let's look at if I have a question which is it doesn't ask for angle of incidence. It just the angle of incidence is not checking for Brester's angle, but sometimes you can check. Okay, so this will be useful, right? So from there you can if you work out, you can actually use this angle to get the R, and you can use these guys to solve for other problems. Okay, so using this angle we can get RB, and then using this formula we can get I prime, and there will be a known A is a known, and then this one I can write down EB, and then EB and this I equals to 60 degrees. So you can see that from here is E equals to A. So refraction here, relations of this with that, and then refraction here, that will give me an equation in A. So I should be set up an equation in A. Okay, and when you get E and call it A, so we should use this to set up equation in A. All right, so first thing to get RB, refract, so this NB sine RB equals to 1 times sine 60 degrees. and this is square root of 3 sine RB, and this is square root of 3 over 2. So square root of 3 cancels out, and so RB is equal to 30 degrees. So we got the 30 degrees for this, and from so this angle here will be I prime B equals A minus RB, and so A minus 30 degrees. And then over here, so 1 times sine of EB is equal to, these are all B's here, B's here, B here. Sine AB is square root of 3 times sine I prime of B, and so it's square root of 3 sine A minus 30 degrees. Sine of EB is from here again to sine of A, and you have a square root of 3 sine of A cosine 30 degrees minus cosine of A sine 30 degrees, and then divide by sine A on both sides, because sine A is definitely is not 0, you know, this angle is A, so, and also divide by square root of 3. So we can get rid of this one here. So we have a 1 over square root of 3. This I'll just leave the square root of 3 alone, because so this 1 equals to this cancels that. Cosine 30 is square root of 3 over 2, and then you have a, this is cotangent, this with this cotangent A, sine 30, we just had a half, right? And so we let's just, we have to, in exam time we have to do really fast, and so this is square root of 3 over 2 cotangent to A, and bring this over here, square root of 3 over 2 cotangent of A is 3 over 2 minus 1 is half, and this got cancelled out. So cotangent of A is 1 over square root of 3. So I don't know if you remember cotangent. If you don't remember, convert that to tangent of A, that becomes square root of 3. Either way, you're going to get A is equals to and it's something, let me check. Okay, check that, checks that, checks that. So A is actually 60 degrees. See, not 30 degrees, 60 degrees, 60 degrees. All right, so A has to be 60 degrees, and so it is, B is actually over here is one of the answers which says is 45 degrees, and I don't think it's can be, the only way it's going to be is both sides got cancelled out. So both sides in this formula got cancelled out, but I don't see, I quickly checked through this, I don't see any place cancelling out. I don't think cotangent of A is not 1. Okay, so that didn't turn out. So that just tells me B is going to be not right. Okay, so B is not right. So we have A right, B not right, and angle of refraction for the blue light in the exit plane. We also solved this. While solving this, we had E of B, so A 60 degrees, so we have A 60 degrees, but while we're solving it, we solve the exit angle also is A, so the E of B is 60 degrees, and so that actually solves D, angle refraction for the blue light, is this. So the D is correct. So the D is correct. So what have we found so far? We found A correct, and B not correct, and then D correct. So we found this, and we have to decide about C. So we will decide about C. Okay, so what's the C? Refractive index of the material, the prism for the red light is √2. Okay, now we are going to go back to our red light. And red light, if you look at the question, the red light is actually comes out at minimum deviation. Okay, so for the red light is 30 degrees. Okay, so so I'm given that, I just found that. So this is given at 30 degrees, and this is given at 60 degrees. This is 60 degrees. So just this formula, I should immediately do this calculation. So sine 60 plus 30, this degrees over 2, this degrees over 2, and sine 60 degrees over 2, and so the sine of 90 degrees, 1 over square root of 2, and 30 degrees is half, is square root of 2. So it says, let's look at answer here. Refractive index for the red light is square root 2. So this is also correct. So we got a C is also correct. C is also correct. So this is for the question number 2. Question number 2. So okay, good. So you can see that this actually is a problem where what is it testing? It's testing. Sometimes when I'm done with the problem, not in the test time, but just preparing for the test, I kind of want to know what's the point of this question. The point of this question is, okay, how about do you have a plane polarized? What do you know about plane polarized light? And what do you know of the Brester's angle? Okay, and also what do you know about the minimum deviation formula? Do you remember the minimum deviation formula? So that's another point for this question, because if you don't remember it, or if you can't figure it out in this part, you probably can't do this problem, right? Usually prism, the deviation from angle formula, it's a lot of work to find that on the spot. So I will definitely say that there are some formulas it will be best for you to memorize. And let me just over here. So these are the formulas. Let me put this up here so that you know in the future if you want to say what formulas do I need to memorize. So actually this is a formula that I would say probably will help you in solving prism problems in the future. Okay, and it's probably best to kind of memorize them. All right, so I'm going to stop this.